Hello and welcome. In this video, I will explain to you the concept of resource peaks and why this is important for understanding the problem of resource shortages. Have you ever heard about the term peak oil? Oil is a good example of a finite resource. Peak oil describes the concept that extraction and production of oil grows until a maximum or a peak is reached. After this peak, the availability of the resources gradually declines to eventually reach zero. What is the process behind the shape of this peak curve? At the start of the curve, resources are abundant and cheap and easy to extract. Gradually, however, the easily extractable resources are depleted and discovery of new reserves is more difficult and extract. This process is shown here in the increasing drilling depths of oil wells. After some time, however, even more costly and high-level technologies cannot compensate for a decline in the resource stock. So resources become so difficult and costly to extract that they are virtually inaccessible. Two recent developments in the deep ocean, offshore and Arctic drilling for oil are examples of this. Peak oil then marks a turning point for mankind that will cause dramatic changes in the world's economic and social system. Why, you may ask? Well, look around you. The cars that are driving in your city, the plastics that you use, and the energy you use rely on oil and fossil fuels. Therefore, dramatic changes in many aspects of lifestyle can be expected as resources are more costly and no longer available in abundance. Peak oil also stands for the point where investments into alternatives or solutions to resource shortages are critical. Similar concepts to that of peak oil also exist for other resources, such as phosphorus. P is an essential element in the DNA, cell membranes, protein structure, and energy households of all organisms. P, or phosphorus, is mined from phosphate rock, shown here, which is a non-renewable finite fossil resource, like oil. Much of the P that is mined is directed to agriculture for food and feed production and is lost to groundwater or via runoff and erosion to streams. The fraction taken up by plants goes to the cities as food, where the food is consumed and the phosphorus is excreted to waste and wastewaters. And eventually much of this phosphorus ends up in the ocean, where it is very difficult to be recovered again. So it is estimated that peak phosphorus will occur within the next few decades, with a total depletion of P to follow in as close as a century. The implications of this peak phosphorus can become potentially dramatic, such as food shortages, as there are no substitutes for P. An example where the concept of peak resource is applicable, but where a way to resolve resource shortages has been apparent, is copper. Copper is a valuable mineral used in all of our technical appliances. In this figure, some annual copper extraction rates of recent decades are shown. As you can see, there is a sharp rise of its mining. Since copper is a finite resource, at some point in the future new production from Earth should peak and diminish. But, unlike fossil fuels, copper can be easily recovered and reused. It has been estimated that at least 80% of all copper ever mined is still available. by having been repeatedly recycled. For instance, in 2011, recycled copper provided 35% of the total worldwide copper uses, and this percentage is expected to further increase. But what does that mean for peak copper? The moment where the peak copper will occur is not yet envisioned, and certainly not upon us for the next centuries. And this is mainly caused by the recovery and reuse of copper in our society. Indeed, for copper, and hopefully for phosphorus, a peak and a subsequent decline may never occur if we are able to take two essential steps. One, to reduce our demand, and two, recover and reuse these valuable resources from waste materials and waters. When will you start reducing, reusing, and recycling?